Hello grade 12s, welcome to my channel, and today we're going to discuss a maths paper 2 that is rather slightly different from the common papers you are used to. This is something rather special to me. What makes it so special is the fact that this is the paper I wrote myself in my final exams. That was back in 2005, and we can appreciate that this is a higher grade question paper, so a lot of thinking is necessary here. All right, so that's good. Guys, we cannot say much without paying our respects to this gentleman, Sir William Smith. He taught maths and science on SABC 3 in the afternoons back in those days. I mainly learned physical science from him, because at the time he was teaching physics, and yeah, I can say I learned a lot in how he approached most of the questions, but there were days where you could see him standing in for Moira and did some maths questions. He was truly a legend, someone who truly transformed how I do things when it comes to maths and physics, and he influenced my ability to truly picture things, to draw a sketch of something given to me in an abstract way, so that I can make sense of it and essentially proceed with the necessary activity. So we know that this was a great man. He was a visionary and he acted upon it. We cannot thank him and his team enough for their efforts. It was a great honor and privilege to have learned from him. Let's observe a moment of silence for his passing, starting now. Thank you guys for staying on. I know his family already knows that they had a great man among them, and I hope they be comforted by the legacy that he leaves behind. He was truly a great gentleman. All right, let's look at our maths here. So instructions are to be read, but instructions of this nature and that nature are very important. Obviously here we are told that the number of decimal digits to which answers must be rounded off will be stated. So there's no specific commission to a particular number, so we pay attention to local instructions. Now we did analytical geometry, trig, and Euclidean. There was no statistics, but essentially statistics took up most of, trigonometry took more of the questions that could be added in statistics. Now let's see, instructions say use analytical methods in this section, and essentially construction and measurement methods may not be used. This is just to say you cannot draw this diagram to scale and then measure the length of RP if the question is on determination of RP. We need to use the distance formula. Otherwise, constructions are still allowed. Okay, let's do question 1. So we have 1.1. We are told here that A, a point in the second quadrant, B, another point in the second quadrant, and C, which is a point that could be in the first or fourth quadrants, are points in the Cartesian plane. and we are to calculate the value of P if AB is perpendicular to AC. Okay, so we need a sketch for this to be able to proceed properly. Okay guys, so here is our sketch nicely drawn, and what we can appreciate is the fact that essentially this would be the orientation of these lines in relation to each other. Obviously, we know point C could be a point in the fourth quadrant if P is negative, or it could be a point in the first quadrant if P is positive. But of note is the fact that whatever the value of P should be, this sketch dictates that it should be a value less than 2. So we can make sense of it in that manner. Okay, let's start. We know the relationship here is such that the gradients are inversely related. So MAB times MAC should be equal to -1. This implies that y at B minus y at A over x at B minus x at A into y at C minus y at A over x at C minus x at C must be -1. And we substitute, this is 2 minus 4 divided by -6 plus 2 into C, sorry not C but P, minus 4 divided by 3 plus 2 equals -1. This is a half into P minus 4 divided by 5 equals -1. That implies, multiply here, we get P minus 4 over 10 equals -1 over 1. You can cross multiply here, and then what do we get? We get P minus 4 is equal to -10. Therefore P, when we transpose, we get -6. So a near perfect sketch, guys, is important because we can see that we can accept that value of P. So what do we do here? So this substitution and that substitution and the general substitution. So that's effectively 3 marks. And then this gradient would have been a calculation on its own, so that's 4 and that's 5. Easy 5 marks. Okay, great. So let's do the next question. 1.2. We are told that in the diagram alongside point P, a point in the second quadrant, point R, another point in the second quadrant, and Q are vertices of triangle PRQ. And we can see that essentially point Q is in the first quadrant. We are told also that N is the midpoint of RQ. So this means this line is cut into 2 equal lengths like that. So what can we do here? Well, we can use Rn to find the equation of RQ, and we can find the y-intercept there as well as the gradient. We can use Rn to find the coordinates of Q and therefore determine the equation of PQ. From that equation we can read off the y-intercept as well as its gradient. We can do the same for Rp. We can find the equation mainly. Okay, so we can do a lot of damage there. Now what is best is to start answering. So we have 1.2.1. We need to calculate the size of R, rounded off to 2 decimal digits. So we can see that this is a typical higher grade question, so a lot of work is necessary. So one could easily find the coordinates of Q and essentially calculate all those lengths and then use the cosine rule. It's possible, because what we're interested in is this angle right here. Okay. Or we can make some nice constructions. Let's see. So guys, as we can see here, there is a sketch. I've decided to extend, in fact, draw a horizontal line so that it's parallel to the x-axis from that point R. In fact, let's show R here because it's messed up now. And then this would give me the angle of inclination of RP, which is beta. But I also know that if I extend this line RQ there, I get that small angle theta, which is the negative component of the angle of inclination, which will be equal to this angle inside, which is alpha. And that is because of vertically opposite angles. And now alpha plus beta gives me angle R. So a smart construction can work. So to answer this question, we can say construct or construction as shown. Now we're just trying to avoid to say a lot. The sketch is given and you just annotate it. What do we know? We know that tan beta is equal to the gradient of RP. This implies that tan beta is y at P minus y at R over x at P minus x at R. This implies that tan beta, y at P is 5 minus 3 divided by minus 2 plus 6. This implies that our tan beta, this is basically 2 over 4, which is a half. So we can say, therefore, our beta would be arctan 0,5. Now we cannot guess this. Let's put it on the calculator. So this gives us a 26,565 degrees, just to protect our answer here. We also know that basically tan alpha is equal to tan theta. Why? In fact, let's say the absolute value of tan theta. Why is that? It's because alpha and theta are vertically opposite angles. Nice and easy. Okay, so this implies tan alpha. The reason I'm introducing an absolute value is because I know this would be negative, so it would give me a negative 10. But I want a positive answer, so I have to take an absolute value, okay? So this is the absolute value of y at n minus y at r, because this is the gradient of nr. X at n minus x at r. Nice and easy. Tan alpha would be, we substitute, y at n is 2 minus y at r, that's a 3, divided by minus 1 plus 6. Okay, so this implies that tan alpha, now when you take the absolute value of this, this would have been minus 1 over 5, so it becomes a positive 1 over 5. Okay, therefore alpha is the arctan of 0,2, right? because 1 over 5 is 0.2. We cannot guess this. So shift 10 of 0.2 gives us 11,3099 degrees. Then angle R is basically alpha plus beta. That's our construction. This implies angle R is 11,399 degrees plus 26,565 degrees. Therefore, our angle R is, just add the two. So we get 37,87 degrees to 2 decimal places. So this was a bit of a nice question, but labor intensive essentially. So this substitution, that answer is key. We can say this substitution here and this answer, knowing that we're taking the positive and of course getting that answer. We have 4 marks and 5. Wait a minute. Oh yeah, this statement is key. So 1, 2, 3, 4, 5, 6. No man, I'm giving more than I'm supposed to. So 1, 2, 3, 4, 5, 6. Yeah, it's over. I'm giving more is not allowed. So next question, 1.2.2. We then have to determine the equation of Pn. Where is this? So P is a line from P to N. Okay, so we've got 2 points, so we can do it the standard style. Gradient of Pn is y at n minus y at p over x at n minus x at p. This implies that the gradient of Pn is, this is 2 minus 5 divided by minus 1 plus 2. We can make a conclusion that therefore the gradient of Pn is essentially minus 3. Okay? Then we know that Pn as a line is y equals minus 3x plus c. Through point N, if we choose that point, remember we can choose any point. This is going to be 2 equals minus 3 into minus 1 plus c. This implies our c, this is minus 3 with transpose, sorry, it's a 3 with transpose, it becomes minus 3, so we end up with a minus 1. Therefore, y is equal to minus 3x minus 1. Nice and easy. So substitution, gradient, substitution of the point, and the answer. Easy 4 marks. Okay, this one is a standard grade question. So 1.2.3. We need to find the coordinates of L, the midpoint of PQ. So we need the coordinates of Q first. So Q such that x at Q plus x at R over 2 should give us the x coordinate at N, its midpoint. Likewise, y at q plus y at r over 2 should give us the x coordinate at its the y coordinate at the midpoint n. This implies that q, still the x at q minus 6 divided by 2 should be equal to minus 1. Likewise, y at q plus 3 over 2 should be equal to 2. Therefore, q is, we cross multiply there, it's going to be 2 times minus 1, it's minus 2 plus 6, it's a 4. We cross multiply there, it's a 4, we transpose 3, it's 4 minus 3 is 1. Can we accept that? Yes, because this is a point in the fourth quadrant. Again, from the sketch we can see point Q is below point N. The Y value is greater than that at Q. So it's okay. Then we know that we want L. So X at essentially P plus X at Q over 2 is to Y at P, Y at Q over 2, because that's the midpoint. L is X at P is minus 2 plus 4 over 2, 5 plus 1 over 2. Therefore, L, the EL, this is 2 over 2, this is 1. This is 4 over 2, sorry, 6 over 2, that's a 3. Okay. So that is the coordinates of L. But what do we note, guys? Do we see that the Y value at L is the same as the Y value at R? So this is suggesting that this line RL is a horizontal line. So that means L is here. Okay, great. And this is the midpoint of PQ. Okay, how do we score marks here? Well, these substitutions give us a mark and each of those coordinates. And then we can say here again, these substitutions, maybe, maybe not. This is the similar formula, so we may just mark the two coordinates. So probably that's how the 5 marks are scored. Okay, last question, 1.2.4. Now we are told to determine the coordinates of A, the point of intersection of the medians of triangle PRQ. So guys, what do we know? So this is one of those questions where you can say it's a typical higher grade question because a lot of thinking is necessary. Now what do we know about medians? Well, a median is basically a line from one vertex of a triangle to the midpoint of the opposite side. So it's a median in that it cuts the opposite side into 2 equal lengths. So that means PN is a median as well as RL is a median. Okay. So guys, if we can just review some theorem that has something to do with this. We know that the median theorem of triangles states that the point of intersection of the medians, meaning the lines from one vertex to the midpoint of the opposite side, is called the centroid. So this makes our point G our centroid. and is located at 2/3 of the length of each median. So these conditions, we can see that G is the centroid. Okay, and then 2, we can easily see that BG should be equal to 2/3 of BE. Okay, so this is what we can draw from the median theorem of triangles. So guys, this is just, some extra notes. So what we can see is that already this line RL is the median of PQ, as well as PN is the median of RQ. So essentially these are medians. And where do they intersect? Right there. So that's point A. So this is the point in the second quadrant. So we can just say here RL is such that y is equal to 3, because the y value at R is the same as the y value at L. So that makes it a horizontal line. With y at R equaling y at L equal to 3. Okay, so what can we say? We can say then A is the centroid. That's really a centroid such that, okay, what can we say? We see that y of RL is equal to y of PN. That is evident. They intersect there. So this is 3 equals minus 3x minus 1. So this is just simultaneous solving. Transpose this, we get 3x is equal to minus 4. Therefore, x at A is going to be 4/3. All right. We can say here also, we know that y at A is essentially 3, because A lies on RAL. So we can just easily say A, maybe let's just say this, R, A, and L are collinear points. Nice and easy. So we can make a conclusion, therefore, that point A is going to be minus 4/3 is 2, 3. Could we accept that answer? Yes, we can, because we see that obviously the y value there is a 3, which is fine, which places it in the second quadrant. The x coordinate is negative, and sorry, it's just to the left of point N. So this is a minus 1. This is a minus 1 comma something. So this is acceptable. Okay, so this determination warrants 2 marks. The statement and reason, solving simultaneously, getting that, and probably the statement and reason as well. So we've got 1, 2, 3, 4, 5, 6. So we can have the 6 marks on offer. The final answer has already been marked, so that's it. So barring any mistakes, folks, we would have scored 26 marks. And obviously the last question is a bit challenging. All right, let's move on, guys, to the next question 2. Right, obviously the diagrams are not as small on the diagram sheet, so there is enough room there for some serious sketching if necessary. So question 2, always a typical grade 12 question. In the diagram alongside, a circle with center M touches the y-axis, meaning it is tangential. Okay, at point P, where B and C are integers, meaning since this is the point in the fourth quadrant, we know that we expect B to be positive and C to be negative. But now where is this point P? Now if we look at this, these ones are tangential, maybe right around that. So we can call that one point P, and of course the x there is 0. What is the y? Now if we draw a line from P to the center, which is the radius, what can we appreciate? We'll appreciate that the tangent is always perpendicular to radius. Right. And if that's the case, this line is perpendicular to the y-axis, so it means this line is parallel to the x-axis. Okay. Because the x-axis themselves are perpendicular to the y-axis at the origin. Okay, so that is fine. Now, if this is a horizontal line, it means the y value at M is the same as the y value at P, so that is a C. So we've got point P, essentially. Now we read on. Point Q, which is 3 and 1, a point in the first quadrant, lies on the circle. Okay, but now where is point P? Well, we've got options. If this is a point in the first quadrant, it could be directly above point M, but it could also be to the right of point M. So Q could be there, or it could be to the left of point M, the center. Now we don't know where point Q is, because until we know those coordinates, we cannot place it in its exact position, but we can place it where we expect it to be. That's something that is elusive. M lies on the straight line. Now this straight line is best written like this, because we can understand that this is some equation of some diameter of this circle. So let's draw the diameter. So we can see that it has a negative gradient, and it's fairly steep. Okay. So if anything wasn't drawn, it must be in this manner. All right. Okay, so this is the line y equals minus 2x plus 4. And it passes through the center of our circle. Great. Is there anything more? Well, I think our analysis is okay so far. Now we are told P and Q are not shown. We are very certain of the position of point P, but point Q is still elusive at this moment. Now let's go on. We are told to write down the coordinates of P in terms of B or C. We've already done that. So we've got 2.1, 0.1 from 2.1. What is that? We know that point P is 0 and C, essentially. So we get our 2 marks and we move on. 2.1.2. We are to determine the equation of the circle in terms of B and C. Okay, so we know that circle, center M, is given by x minus the x at the center all squared plus y minus the y at the center all squared equals, what would be the radius? Now if we pay attention to this portion right here, that radius is essentially the distance from the origin to the region of B. So this is essentially B units. Okay, whatever the value of B would give us the radius. So we can say this is B squared. This is it. So we can say substitutions for the left and the right overall gives us 2 marks. So fairly easy question there. So we have 2.1.3. Now we need to determine the numerical values of B and C. So this is a typical higher grade question. So obviously this would require some simultaneous equations and some serious manipulation. So what can we use? If we draw a line from the center to where Q is, we don't care at the moment if Q is there or not. All we care about is the fact that we will appreciate that this line is equal to that line. Why? Because these are a D. And we can use that to derive an equation. So we can say here PM is equal to MQ. Because these are a D, this implies we can actually square this thing. And what we do to the one side, we do to the next. The reason for squaring, we know that we're going to end up with the square root sign. We don't want it. This implies PM squared is basically B squared equals, from the distance formula, this is going to be B minus 3, meaning x at M minus x at Q all squared into y at M, which is C, minus y at Q, which is 1 all squared. We FOIL it out. B squared equals, this is going to be B squared minus 6B plus 9 plus C squared minus 2C plus 1. So we've got like terms. So they'll do the honorable thing and resign themselves from the office here. They are not needed. Now we can write our quadratic in standard format. C squared minus 2C minus 6B, 9 plus 1, that's 10, equal to 0. We cannot simplify further here. Maybe we can say here, therefore, and make that equation 1. We know also that essentially with this line y equals minus 2x plus 4 through point M with B and C, this implies that C is equal to 2 into B plus 4. We can say therefore C is minus 2B plus 4. We can make that equation 2. Now we can then put 2 into 1, because these are all in terms of B and C, such that where we see a C, we're going to write minus 2B plus 4, and then we square minus 2, and then we will have minus 2B plus 4 minus 6B plus 10 is equal to 0. This implies when we FOIL it out, we get 4B squared This is minus 8 times 2. This is minus 16b plus 16. Okay. This is going to be plus 4b minus 8 minus 6b plus 10 equal to 0. Now we handle like terms here. So we will essentially have 4b squared. Now minus 16b plus 4b, that's minus 12b, minus 6b, that's minus 18b. And then 16 minus 8 is 8 plus 10. That's 18. We can divide by 2. We get 2b squared minus 9b plus 9 equal to 0. We can factorize. So this is 2b, this is b, minus 3, minus 3. So minus 2b, minus 3, that's going to be minus 6b, minus 3b. Yeah, it works. So therefore, we know that b will be equal to 3 over 2. Is it true? We were told these are integers, so it cannot be. Or b is effectively a 3, and that we can accept. We can also conclude that c will be, which substitute there, is going to be minus 2 into 3 plus 4, which is minus 6 plus 4, that's minus 2. Therefore, our m is basically 3 is 2 minus 2. And we can see this is essentially a point in the fourth quadrant. So here the key was simultaneous equations such that one derives those equations. All right, let's see. Now these substitutions are key, and then that equation important. And here the substitution and that equation, 4 marks. Putting one into the other, 5, 6, 7, and I'm sure that is key as well. All right, great. So we have our 8 marks, and we move on. We are told to hence determine the equation of the tangent to the circle at Q. Okay, that's all right. So we've got 2.1.4. Now we can see something that, okay, the x-coordinate of our m is the same as the x-coordinate of Q. So this places Q directly above m. So obviously, guys, you're advised to use a pencil here to avoid problems of this nature where things change around a bit. So when things change, so we know now the position of Q. Q is basically 3 and 1, and it's directly above point M, because this is 3 and minus 2. Okay, so that was not a construction that was given, so we can just do what we do, and we indicate the equality there. All right, so our diagram is set for us to, do our things. So we want the tangent at point Q. So the tangent at point Q will do stuff like this, guys. It's going to be a horizontal line, right? Right, because we know the tangent is perpendicular to radius. So that is the story. So the tangent meets the radius at right angles. And since this is a vertical line and that is a perfectly horizontal line, so this line is also parallel to the x-axis like all the others. So this is the tangent at Q. So what do we say here? We can say the equation of the tangent at Q is given by y. So it's going to be essentially the y value there. The y value at Q, because that's a horizontal line. We can just say y is equal to 1. And then we get our 2 marks. Usually answer only can be given a mark. There's a lot to say, but there's no need because they made it simple. All right, so let's move on to 2.2. Now 2.2 says a circle with this equation is given, and now that format is not the best. So how best can we write this? We can write it by saying this is x. The sign between the x term is a plus. Half of that 2 is 1, and then we square. Then we say the y terms have a negative between them. Half of 6 is 3. All squared equals. We transpose the 6 and then we add 1 squared. That's a 7. We add minus 3 squared. That's a 9. So 7 plus 9 is 16. So this is how this equation should be written so that we can use it. Now we are given some stories here that technically P is a locus point. Now this introduces something else again. What is a locus? Of course, this P is a locus point in the Cartesian plane such that the length of the tangent drawn from P to the circle is equal to the length of the radius. Okay, now let's just revise a few notes. Okay guys, so what is a locus? Locus is a set of points, right, that satisfy a given condition. Okay, for example, a condition like the length of the tangent drawn from P to the circle is equal to the length of the radius of the circle. So that is the condition. But this must be in 2 dimensions, meaning in the Cartesian plane. Now this could be a shape or a graph, right? Now think of a parabola. A parabola is symmetrical about the axis of symmetry. So basically it's a set of points on the horizontal plane that are equidistant from the axis of symmetry. That is a locus. A straight line graph, remember, it's a set of collinear points, meaning the gradient between any 2 of those points is the same. So there has to be something fixed about these points. And then, of course, a circle, we know that it's a set of points on the circumference which are equidistant from the center. So that is what a locus is. It was hardly really well explained when we were students, but yeah, luckily guys, you are getting it now. All right, so now let's depict what we are given in a sketch. Okay guys, to draw a near perfect sketch is important. So we're just drawing the sketch of what we are given, and that this locus point P from there to the circle would give us the tangent, but the tangent must be equal to the radius, and obviously the radius is the square root of 16, which is 4 units. And we can see the center is going to be -1 and 3. So that is what we have. Okay, so we've got a nice sketch. Now let's use it. Let's put it to use. So we have 2.2.1a. We need to determine the length of the radius. That's easy. First of all, we can say the circle is such that we've got x plus 1 all squared plus y minus 3 all squared is equal to 16. To write in the standard form was important because it wasn't given. We can say here, therefore, the radius is going to be equal to the square root of 16 which is going to be equal to 4 units. Remember, the radius is a distance, so we need to make sure the units are set. So writing that equation in standard format and taking the square root sign, and the answer is those 3 marks. Okay. We have B. B says we need to determine the equation of the locus of P. Now this is a typical higher grade question. Now we need to be strategic. So if we look at this relationship, we'll see that although we don't know the point B, which is the point of tangency, but we know the size of the tangent length, it's 4 units. And this is right angled. So this means we can actually do something about it and say, look, how about we join point P and A? So what happens when we do that? We get a right angled triangle. But do you see what is so nice about this right angled triangle? It's isosceles. Now I don't know why people always say a right angled triangle is a special triangle. I mean, it's a special scaling triangle. But remember, it can be isosceles, so we can just easily say it's a special triangle rather than it's a special isosceles. Okay, now let's have a look here, guys. So what we see, guys, this is a right angled triangle. Now we can actually decide that even if we change where P stands, this length PA will stay the same, because we cannot bother ourselves with that point B there. So we can easily play a very smart trick. Of course, this sketch must be present for this to be done. So we can say here, essentially, PA squared should be PB squared plus AB squared. This is from Pythagoras. I don't know, my Pythagoras needs a lot of work here. Let me leave it here. Now what does this imply? This implies PA squared. Remember, that's the distance. We can use the distance formula. X at P minus X at A is going to be plus 1 all squared. Y at P minus Y at A all squared equals. Now PB is basically 4 units squared plus AB is also 4 units squared. We can say, therefore, our equation of the locus is going to be x plus 1 is 2y minus 3 all squared is equal to 32. Now, don't you see this is an equation of a circle? It is. Okay, maybe let's do something here to answer properly. No, not like this. I don't like the way I have phrased my stuff. We can write here equation of locus P is such that. Now we use the relationship because we use the relationship every time we append this equation. So obviously, guys, there's a mark for that. There's a mark for the left-hand substitution, the mark for the right-hand substitution, and the overall equation. So easy 4 marks, not a big deal. Now let's look at C. Not C, there's no C. Oh. So go declare. So we want to do 2.2.2. We are asked a question now to describe the locus obtained fully. All right, we can see that it is the equation of a circle with center -1 and 3, radius which is equal to the square root of 32 units, and is concentric to the smaller circle. That's it. So if we can just draw this one just to show this situation here nicely. So we can see that if we draw a circle around here, it should be doing things like that. Okay guys, it's not going to be perfect, but we can see that point P, the locus, is obviously sharing the same center, and these are concentric circles. So this we can do to picture what we are talking about. Alright guys, so this one was easy. So it is an equation of a circle. We state the center. Obviously specifying that it's an equation of a circle is important, and then getting the radius and the concentricity to the given circle I think is also important. So we can have, guys, our last 3 marks in this question. Barring any effects of mistakes and stuff, we could have taken these 24 marks nicely. Okay, this question wasn't too bad for a grade 12 question, but obviously question 2.1.3 is a heavy one. Okay, so let's move on. All right, question 3, trigonometry. Let's see what triangle measurement has for us. No specific instructions here, so we just go in and start working. We are told here in the diagram alongside P is the point in the Cartesian plane such that OP is 16 units, it's indicated, and the size of the reflex angle theta is 200 degrees. Okay. Alright guys, we do the usual. We just draw our terminal arm back into the x-axis and we get ourselves a right-angled triangle. So the question says we need to determine the coordinates of P rounded off to 2 decimal digits. So that's easy. We know that if we want x, we're going to say cos of theta is going to be x in general divided by r, the terminal arm. This implies that cos of 200 degrees is going to be x at P over 16. That is over 1. So we can cross multiply here and see that our x at P would be 16 times cos of 200 degrees, which we need to put into the calculator. 16 into cos of 200 gives us a minus 15,04 to 2 decimal places. This is a coordinate in the Cartesian plane. We don't worry about other things. Also, we want the y value. So sine theta is going to be y over r in general. Specifically, sine 200 degrees is going to be equal to y at P over 16, and that is over 1, cross multiply here, what do we get? We get that y at P is 16 sine 200 degrees. Let's see, 16 into sine 200 degrees gives us a minus 5,47 to 2 decimal places. Therefore, P is the point minus 15,04 is 2 minus 5,47. Alright guys, so do you see how this notation of the coordinate system helps? Using the semicolon to separate coordinates. When we've got decimals, it accommodates it nicely, but doing any other thing will leave you crying. But hey, cry or don't cry, it's up to you. So that is the one. Substitution is the one. Yeah, that is it guys. The coordinates don't really get a mark, but we have to write it in the ordered pair. Let's move on. We have 3.2 where we are given sine of 54 degrees is equal to P, and we must always show this as a ratio. So we are to express everything below in terms of P without using a calculator. Okay, so we need a sketch. Okay guys, there is our sketch, nicely done. So always calculate all possible angles and all possible sides in the standard fashion. Now we start answering. So we've got 3.2.1. We need sine of 594 degrees. This is sine of 360 degrees plus something. So let's see, we can use our calculator in a nice way. Just say 594 minus 360, which becomes 234 degrees. So we need to show this reduction. Otherwise, not showing it means we used a calculator. So again, sine using reduction formulae, in principle, irrespective of the angle, is just in the first quadrant. So this is 234 degrees. It will correct itself. We need to reduce this further. It's going to be 180 plus. This gives us 54 degrees. Okay. Now we can finally reduce this. This is going to be minus sine 54 degrees. And what is sine of 54? It's P. So this is minus P. Okay, easy stuff. So using reduction formulae is important, guys. So usually this reduction is a mark, but you cannot just jump from that to here. We need to see these steps. That's the essence of saying do not use a calculator. So we've got our easy 2 marks here, not a problem. So we've got 3.2.2. We need to find cos of 18. Now definitely we don't have special angles to give us that. So you see, calculating the other angle could be put to use. If we say 54 minus 36, we can borrow 1 from 5 to 4. That becomes 14 minus 6, that's an 8. Then 4 minus 3, it's an 18. So definitely this is cos of essentially 54 degrees minus 36. So you see, the strategy, guys, always works. Alright guys, so always remember our 3-step approach when it comes to trigonometry, because this is the algebra of paper 2 essentially. So both direct and applied applied, we're talking about brackets with reduction formulae and co-ratios or co-functions, AS with special angles, and then we can factorize, we can use identities. And you can see here we used reduction formulae to sort out. Now here we're going to use identities. So this becomes cos 54 degrees, cos 36 degrees. The sign changes to sine 54 degrees, sine 36 degrees. So the formula sheet is available in case one has forgotten. So we use our diagram now to substitute things here. Cos of 54 is adjacent over hypotenuse. So this is the square root of 1 minus p squared over 1. Cos 36 adjacent over hypotenuse. This is p over 1. Plus sine 54 was given as p over 1. Into sine of 36, this is opposite, which is square root of 1 minus p squared over 1. Now we simplify further, Bodmer style. This is p square root of 1 minus p squared plus p into square root of 1 minus p squared. And these are like terms. This is going to be 2p square root of 1 minus p squared. So that is sorted, guys. So we were scoring how many marks here? 6 marks, okay. This is typical. The expansion in the correct way. And then we didn't know cos 36. We also didn't know cos 54 because this mark comes from that determination. In fact, we can easily just say left hand side here, right hand side there. So 4 marks. And then we can say 5 marks for the final answer. And the 6th mark, it's because this was a calculation on its own. So that mark comes back to us. All right, because it's part of the second calculation. So 3.2.3. Now we have this story right there, okay? So we've got 10 of 27 degrees plus cot 63 degrees divided by 1 plus 10 207 degrees times cot 117 degrees. So what do we do here? Of course, using our doctor's approach, we inspect and what. But when I look at this, I get the impression of the 10 compound angle identity. So 10 of A plus B used to be, we used this one. It's going to be 10 of the first angle plus 10 of the second angle divided by 1. The sign changes minus the product of 10 of the first angle and 10 of the second angle. Okay, so this is what I'm thinking. Of course, if that was a negative, so we would have the negative sign there, and then this one changes to a positive. And also, guys, this could also mean something like 10 of a double angle A is equal to, this would be 10 of A plus A, so it would look something like this. This become like times 2 times 10A over 1. The sign is still minus 10 squared A because that would be the product. So this is what I'm thinking about, seeing what I am seeing. But now we have to confirm this to be the case. Now, remember, you guys don't use these identities anymore, but what was so special about them with us is that even though we were using them, they would not be provided in the information sheet, so one would have to memorize them. So I hope this is right, because I don't remember this so well anyway. Let's move on. Now we need to sort this out. Remember the three-step approach, guys. It's still there. So this is equal to, there's nothing we can do about 1027 degrees plus cot. We can try to use BODMAS in terms of co-ratios. We want to make it look like that. This is the same as cot of 90 degrees minus 27 degrees. Where did I get this idea? It's because this angle plus that angle is 90 degrees. So whenever you see that, you can change them. But this comes from a proper inspection. So this is 1 plus. Now we want to deal with this. This needs reductions. So this is 10. 207 is 180 degrees plus 27 degrees. Okay. Into cot 117 is basically 90 degrees plus 27 degrees. Okay. So you can see that we're using co-ratios so far and reduction formulae. So we're still on step 1, BODMAS. But we're already trying to be strategic. So we have 1027 degrees plus. Now the co-function of cot is 10. Now we take the acute angle. Nice and easy. Then we have 1 here, plus we reduce this. This is a positive 10, 27 degrees. This one is 90 plus. Second quadrant cot is negative, and so will the co-ratio. So this one is, that's once again done, minus. Sometimes isandla sami sivele sibhale nje izinto endingazazi. So what do we notice here, guys? As we sort this out, these are like terms. So this is 21027 divided by 1. This negative affects this product. We've got 10 squared, 27 degrees. What does it look like? The 10 double angle identity. So if we have it expanded, we can shrink it. So this becomes 10 of 2 times 27 degrees, which is 10 of 54 degrees. Now 10 of 54 in our diagram is going to be opposite over adjacent. The opposite side is P. The adjacent side is the square root of 1 minus P squared. Okay, so that's the answer. So you can see, guys, here that we had to do a lot of sorting up the reductions, and then we used BODMAS to multiply out, and then we used identities, and we used our diagram. So this is how these questions can be scored. Of course, there's many ways of dealing with this, but others can be quite labor intensive and very scary. Okay, let's move on. Let's mark this thing 6 marks as well. Obviously, guys, what matters is this reduction, but we need to show where it came from, but that is important. And then this reduction also is important, as well as that reduction is important. So those 3 marks come from there. And then showing that we can find this step. So that's the 4th mark. From there, shrinking it using double angle identities. How many marks here? 1, 2, 3, 4, 5, and then 6. Okay. All right, guys. So barring any mistakes, but if you spot any, please shout. we can safely say we sorted that first question of trigonometry. All right, so let's move on, guys. Now, strategically, this page, we just landed into it nicely. This is now functions, so we will need to draw some graphs here. So we can do question 4 here. Now, question 4, we are given in 4.1 that f of x is basically the standard cosine graph shifted down 2 units. So it helps to interpret what is given, because an interpretation makes life easy. This is again the standard sine graph shifted to the left 30 degrees. So that's what we have. So 4.1 tells us to use the set of x's provided. Now we don't. I used this one to draw the sketch graphs of the curves of f and g for this domain, minus 120 and 60, and to show clearly all the intercepts with the x's, coordinates of all the turning points, coordinates of all the end points. Okay, great. Let's just draw our Cartesian plane nicely. Oh, before we do that, we need our intervals. So since the period for both sine and cos is 360, we know that our intervals is going to be the period now in these graphs divided by the 4 quadrants. So this gives us 90 degrees. But now we see that there's a 30-degree shift, so we need to accommodate a 30-degree shift of certain points for sine. So we divide that by 30, and that would give us 3. So meaning 3 units would amount to 90, where 1 unit is 30 degrees. So we can draw our Cartesian plane nicely. Maybe let's extend it a bit. So now let's see, we can use this as 30 degrees and then 60 degrees, and that's over. We can show the origin like that. That's the y, so we can say here minus 30 degrees, minus 60 degrees, minus 90 degrees, minus 120. So we can say this is 0,51, 0,5 minus 1. All right, so that is essentially the grid. So now how do we deal with this? Okay, we deal with them like this, nicely. No manga business. We can start with the cosine graph. We know cos of 0 is 1, but we take it down 0,5 units. Okay, easy. Now cos of 30 is root 3 over 2. Now let's just use our calculator there. Root 3 over 2 is effectively 0,9. So when you subtract 0,5 there, we get a 0,4 essentially. So this one gives us a 0,4. So maybe something like that here. And then cos of 60 is a half. We take it down half units, so it becomes 0 there. Okay, great. Now the same will happen on this side. It's going to be up to 0,4. Okay, and then at 60 it has to cut. At 90 it's what would have happened at 60. No, don't lie. Cos of 90 is a 0, and then we take it down 0,5 units down. 120 would have been a half. It goes to minus 1. Okay, let's draw the graph. Okay, there's the graph of f. Nicely done. Spare that this side is trying to mess with me a little bit. Not too much, but just nje. Khona nje wena imshikashike funa ungenza wona. So sebenzisa masebenzisa brown. And then this one is just shifted 30 degrees. So we know sine of 0 is 0, but that shifts to 30 degrees left. And then we know sine of 30 was going to be a half, but that shifts to 30 degrees earlier, which is here. And then we know that essentially sine of 60 is root 3 over 2. It comes here. So that is closer to 1. So that's 0.9 somewhere there. And then we know that sine of 90 would have been 1. It shifts to 60 degrees, so it becomes here. All right, great. Same story here. We know cos of 30 would have been a half, negative half, sorry. It goes to minus 60 degrees, which is 30 degrees earlier. Then sine of minus 60 would have been minus 0.9. So that shifts to 30 degrees earlier, which is around here. And then we know sine of minus 90 would have been minus 1. It shifts to 30 degrees earlier. So that is the stories there. So what do we do? Okay, guys, so that is the graph of G. So with everything correct, we take our 9 marks. Nice and easy. So let's do 4.2. 4.2 tells us to use the graphs drawn in 4.1 to determine for which value or values of x in that given domain is that situation happening. So let's see 4.2.1. We've got cos of 60 degrees minus x less than 0. Now, obviously, this suggests that this graph should look like one of the graphs above. Now, how do we decide what to do because it looks funny? Should we use the expansion here? We're going to get cos and sine x, cos and sine x. So, it's going to be a bit of a situation, I'm sure. But how about we try to use our 3-step approach here? We can do reduction formulae, we can do cofunctions. Could we attempt cofunctions here? Maybe let's try and see. Now cofunctions, if we try them, because we're just trying to make it look like either this or that. This is the same. If this was a cos, this could have been a sine of 90 degrees minus this compound angle. And that is less than 0. This implies we've got sine. Now we just simplify this whole thing. 90 degrees, we distribute that negative is minus 60 degrees. That becomes plus x less than 0. It looks like it's working already. This is sine 90 minus 60 is 30 degrees. We can just make the x lead the way. Less than 0. So basically this is the sine of, this is basically G of x less than 0. So when do we see that? From minus 30 degrees all the way to negative infinity. So we can say here, therefore, our x must be less than minus 30 degrees. Nice and easy, okay, but a little bit tricky as well. So 3 marks. I am quite certain, guys, that this technique is mark worthy. And perhaps this one or this last one doesn't really matter. And then the final answer is up. in our pocket. So we've got 4.2.2. Now we've got f of x minus g of x greater than 0. This implies we can take f of x against g of x here. Transpose the g of x, it becomes positive. So when are these graphs in this manner? F of x above g of x. We can see here this is a point of intersection, they are equal. But as we move to the right, the graph of f is above the graph of g. That is the constraint until here they are equal. And then they switch around. So it's between 0 and minus 120. So we can say therefore x must be less than 0 degrees but greater than minus 120 degrees. So usually for this notation we get our 2 marks. Nice and easy. Okay, so 4.2.3, we need to sort out that fraction. So we've got here g of x divided by f of x, and it must be undefined. Okay, so what should this be? It is undefined when basically f of x is equal to 0. That's just a condition, because a division by 0 is undefined. So when is the graph of f equal to 0? At minus 60 and at plus 60. So that is the story. So therefore x must be plus or minus 60 degrees. And that's the answer. Again, we get 2 marks for those 2 solutions. And barring any mistakes, we could have taken those 16 marks. A very easy 16 marks. Perhaps 4.2.1 is just a little bit naughty. Just a little bit naughty. Okay, let's move on to question 5 as fast as our legs can carry us. Forgive the noise in the background. I have trees in the yard, so a lot of birds like to be here. And these hardidas, they like to be here all the time. Okay, let me drink something though quickly. Okay guys, let's not waste any more time. 5.1. We are asked to give an expression for cos of A plus cos of B in terms of the sines and the cosines of A and B. That's easy. This is cos A, cos B, the sign changes, sin A, sin B. So this is just literally a free mark here, because this formula is given at the end of the page, so of the question paper. So here they kind of wanted to break the ice, hence or otherwise prove without using a calculator that this is the case. Okay, so we have sine of 15 degrees. Now guys, we will understand that sine of 15 is essentially sine using special angles. This is 45 degrees minus 30 degrees. See, 3-step approach. I'm sure you guys can appreciate the utility of that piece of information, and obviously using the doctor's approach as an umbrella to everything that we do. Now, I'm going to choose the otherwise portion because I don't want to suffer now. I'm just going to use the sine compound angle identity. This is sine of the first angle times cos of the second angle. The sine remains. cos of the first angle, sine of the second angle. We move on. Sine 45 from special angles is 1 over square root 2 into cos 30. This is root 3 over 2 minus cos 45. It's 1 over square root 2 into sine 30 is a half. Just fold this out. We get a root 3 over 2 root 2 minus 1 over 2 root 2. Okay, now we've got ourselves a common denominator here of 2 root 2, and effectively we just get root 3 minus 1. But now that's not what we want, so we can see that the denominator is irrational. So we need to rationalize. So when we rationalize, we multiply by a special form of 1 made up of those radicals we're trying to get rid of. Alright, so we just multiply the numerators, so we get a root 3 times a root 2 minus root 2 over, this is 2 into 2. Now using our set rules, this is as good as 3 times 2, which is 6, minus square root 2 all over 4. Okay, that's exactly what we were supposed to do, so we are done here. A bit of a situation again, guys. Simplification, but we were using nothing but our 3-step approach. Identities, you know, trying to be smart as well, some logic as well being applied. So that's just fun, folks. So we were scoring how many marks there? 6. So this is key. The expansion is key. The left hand side, the right hand side, using our special angles, that's 4 marks. And then the technique of rationalizing, that's the 5th mark. And the final answer. But for me, it's not really the final answer, but I think that root 6, knowing we need to apply set rules there, I think is key. So this is 1, 2, 3, 4, 5, 6. So we take our first 7 marks with a big smile on our face. And then we need to get to 5.2. Maybe let's do it in the next space here. Now we're given an identity here, cot 2x plus cos sec 2x is equal to cot x. Okay, now the first question, we need to prove the identity. Now we know that we take the left hand side and the left hand side is complicated, so we've got cot 2x plus cos sec 2x. What is this equal to? Obviously, guys, 3-step approach is still our friend here. Now, as we reduce things here, we know that cot is basically cos 2x using our identities over sine 2x. Plus cos sec is the reciprocal of sine. So this is 1 over sine 2x. Okay, now BODMAS, we look for the common denominator. The common denominator is sine 2x. Then this will just be cos 2x plus 1. Okay, And then what do we do here? Cos 2x, we want to get rid of that 1, so we can use the 2 cos squared x minus 1 plus that 1 divided by, we can expand this one into 2 sine x cos x using our identities. So the three-step approach, guys, can come naturally once you know things. Okay, these ones are like terms, so they do us the honors of disappearing. So we get 2 cos squared x over 2 sine x cos x. Now we've got like terms, that takes the square, the 2 takes the 2, and then we have cos x remaining over sine x, and that is cot x, okay, which is equal to the right hand side. When we prove an identity, we must state the left hand side equaling the right hand side. So pretty easy here once one understands what to do. Okay, that was 7 marks. Wow. Okay, this is a mark, this is a mark. Okay, all right, okay. And then this identity used here in this step is a mark 3. And then expanding the sign identity, that's the 4th. Now simplifying until this step, that's what, 1, 2, 3, 4, 5. And then simplifying further, that's 6. Now we can actually decide any one of these steps here. But for me, I believe this step using the LCM or the common denominator is part of the three-step approach using BODMAS directly. So that could be how the 7 marks come about. Okay, but if you are lucky to find the memo to this question paper, you probably will have a clear idea if this approach is considered. But I know that our papers back in the days had multiple options for solving a problem. So if one got a hold of one, it was easy to learn a lot from just one question paper. So try, maybe you might. Yes. Let's move on. So we have now 5.2.2. We are to determine the values of x for which the identity is undefined. Now, when can this identity be undefined? Well, what is the gateway to all of this undefined position would be the denominators. But this is the best place, because if we can say sine 2x is equal to 0, this is undefined, and so this addition is entirely undefined. So that would make sense there, because that's the original equation in a way, with less distortion. So we can say this can happen when sine x is equal to 0. And in fact, it says give the answer as a general solution. So that's easy. So this implies that 2x is going to be equal to, maybe let me try to use as much space as I can. Ooh. This implies that 2x is going to be equal to arc sine of 0 plus k times 360 degrees, or 2x is going to be 180 degrees minus arc sine of 0 plus k times 360 degrees, where k is an element of integers. typical of the nonsense here. This is 2x equals, now arc sine of 0 is just 0 degrees plus k times 360 degrees, or 2x is equal to, this is just basically 180 minus 0, which is just 180 degrees, plus k times 360 degrees, where k is an element of integers. All right, not a problem. We divide by 2 here. We can see that therefore x is 0 divided by 2 is 0, plus k 360 divided by 2 is 180 degrees. Or x is equal to 180 divided by 2 is 90 degrees, plus k times 180 degrees, where k is an element of integers. So obviously here we're not solving for x because there's no domain given, so these are the solutions. Easy, ne? So nothing really strange here. But we're scoring quite a number of marks. So that statement is key. And essentially the gymnastics, I believe. But anyway, we can say this general solution and that general solution is a mark before we get anywhere. And then we can give a mark for that line and a mark for that other line. Yes. Well, there's a lot of things that we did here. So we can score our 5 marks in peace. We move on. Okay, maybe let's do this question in the next page. So 5.3. We need to solve the equation sec squared a minus 310a minus 5 equal to 0. Now we are given a domain, so that means we need the actual values of a. Again, 3-step approach, guys, cannot be overly emphasized. If you don't get it, you will never get it. Sec is basically the reciprocal of cos, so we change it using our BODMAS. Okay, this is going to be cos squared a. Reduction formulae or reciprocals, we can think about it that way. Minus 3 into, now 10 is basically sine of a over cos of a, using our identities, minus 5 over 1 equal to 0. Now we can see here that cos squared a can accommodate all those denominators. So we can say we multiply by cos squared a, which is our common denominator. So what happens? We get 1 minus 3 sine a cos squared a over cos a minus 5 cos squared a equal to 0. This implies we have 1, and then of course these 2, they do us the honors, takes the square, we get minus 3 sine a cos a, forgot to write that angle there, minus 5 cos squared a equal to 0. So what can we do here? We know that our identities tell us that 1 can be expressed as cos squared a plus sine squared a minus 3 sine a cos a minus 5 cos squared a equal to 0. Now we've got like terms here that we can sort out. So cos squared A minus 5 cos squared A, it's minus 4 cos squared A. We can take the middle term, that is a composite of the two. Then we take sine squared A to be the last, equal to 0. I don't know. Just a moment. Okay guys, so our job is done. So we can see this is a trinomial, so we can factorize that thing. And this time I'm not interested in other issues. I just want to get out of this business right now. So I can make this one minus 4 cos A. This would be plus sine A. This could be cos A plus sine A. Right, so that is going to be minus sine. It's going to be minus 4 sine A cos A plus sine A cos A. That gives us the minus 3. He's on. Now guys, since I have decided to clutter things, let's just go on and do it. So this bracket equal to 0, we can solve for sine A and say sine A is equal to 4 cos A, or sine A is equal to minus cos A. Alright, so if we divide by cos A throughout, what do we get? We get sine A over cos A is equal to 4, or sine A over cos A is equal to minus 1. Now we can use our identities. This is 10 of A is equal to 4, or 10 of A is equal to minus 1. Now we're solving. We can say this also implies that A is equal to arc10 of 4 plus k times 180 degrees, or A is equal to arc10 of minus 1 plus k 180 degrees. Okay, maybe let's shift it a bit. I don't like things that jump around. So we can say where k is an element of integers. Yeah, injalo lento. So this implies that A is equal to, now we use our calculator because there's no restriction, so shift 10 of 4 is 75, comma to 2 decimal places. We can make our own choice here, 96 degrees plus k times 180 degrees, or A is, now shift 10 of minus 1 is minus 45 degrees plus k times 180 degrees, where k is an element of integers. All right. Now what do we do with all of this? Remember, we are solving for A. We are given the domain. We can say therefore A is equal to a set. Hi man. Hi boo. Obviously guys, minus 45 degrees would work here, because if we say k is 0, this is minus 45. That's between minus 90 and 0. But this one already is positive. It's greater than 0, so it's out. What about when you say k is minus 1? So when k is minus 1, this one is out because it's going to be minus 45 minus 180. That's already less than minus 90, so that goes. So let's see, 75,96 minus 180. that's minus 104. That's greater than, that's less than minus 90. So that's out. So the only solution here we can get is 45. So essentially we can just get rid of the set story. So the answer here is minus 45 degrees. Wow. Interesting. So again, guys, you saw that this was nothing but three-step approach all the way. So let's see how many marks do we get here. Obviously, guys, this changing here and this identity here is good. And ending up with these identities, the square identity there, that's good. And this equation is good. So we have 1, 2, 3, 4. And then we can say, ooh, that is a mark, obviously. And we can just say any one of these general solutions here. So what is that? 1, 2, 3, 4, 5. Okay, I don't know where the sixth mark, guys, comes from, but maybe any one of these general solutions. But they were effectively a means to an end. Maybe this is good enough, meaning all of those solutions. Sometimes the formal marking guidelines become the absolution. Okay? Obviously, guys, if we haven't made any mistake, we have those 25 marks. And you can see trigonometry is the most labor-intensive segment of this page. But it's not too difficult. Euclidean is a killer. There's not many questions though. Just a moment. Alright, guys, so let's keep moving. We don't have time on our side. So going to question 6. So question 6 on a new page. Okay, good. So we are given in 6.1 that triangle PQR with P obtuse. So this is the angle. Okay. Okay, guys, I had to take care of some people who just came through. Okay, what do we do now? We are to use this diagram and we need to prove the area rule. Okay, pretty easy. So what constructions must we make? Alright, guys, so basically the constructions we need to do is that perpendicular height RS, and we extend the side PQ to S like that. So essentially we can just give ourselves that we are given triangle PQR with angle P obtuse. RTP is that area of triangle P QR is equal to half into Q into R sine of angle P. Okay, so what do? We can just say extend, or what to say, produce PQ to S and draw perpendicular height H. Okay, that's exactly what we are trying to say. So this is key. Then we go to the proof. So what do we say on the proof? We can start on any triangle we want. We can start with the main one. Say in triangle PQR. Right. We see that the area of triangle PQR is going to be half the base, which is PQ, times height, which is going to be RS. Okay, this is equal to a half. PQ is R, RS is H. Okay, maybe let's just write it like that. Say PQR H, okay, times R times H. We can say here also in triangle RSP, we see that there we want to get H, so we can say sine of let's do it, it's going to be RPS is going to be the opposite, which is RS over RP, the hypotenuse. It's a right angled triangle. This implies that sine, now RPS is that small component, it's in the same straight line as angle P. So we can just simply say this is 180 degrees minus angle P. Angles on a straight line, so which is RS. RS is H over P, sorry, RP is Q. Okay, great. So this is over 1. So we can cross multiply here, like so. We can say here, therefore, our H is going to be Q times the sine of 180 degrees minus angle P. Okay, all right, okay. So we can say here then, we know that area of triangle PQR is going to be a half of R times, instead of H, we put Q times, maybe let's do this, Q times the sine of 180 degrees minus angle P. This is equal to a half of R into Q times, we solve this, it simplifies to sine of angle P using reduction formulae. So we can start with Q times R times sine of angle P. Okay guys, not a big deal, just a bit of an essay. I mean, this is how a proof should be constructed, and we just give it. So we get a mark for our construction, deriving this equation, and essentially deriving that equation, 3 marks, and then this reduction here. The answer was already given, so we take our first 4 marks and move on. So we have 6.2. We're given that triangle LMN with LM equals 5 units, LN equaling 2x units, and MN equaling 3x units. Now we can picture this triangle here, like so. Right, so we have L M N. Okay, LM is 5, LN is 2x, MN is 3x. Okay. Obviously, one could draw a right-angled triangle strategically. There's no exclusion of that, but that could be misleading. So I prefer just any scaling triangle because it doesn't cause any trouble unless we need to do that deliberately. Okay, so what are we supposed to do, guys? We're supposed to prove this identity here. See, this is just proving an identity twice, essentially, if you think about it. But all we can see is that L is this angle, and it's opposite this side. So we can use the cosine rule here. So we know that basically MN squared is going to be LM squared plus LN squared minus 2 LM LN cos L. This is the cosine rule. Okay, so we substitute. So this is 3x all squared equals 5 squared 2x squared 2 into 5 into 2x times cos of L, of L. Alright guys, we just simplify now. This is 9x squared equals 25 plus 4x squared minus this is 2 times 5, that's 10 times 2, that's 20x cos of angle L. Now we want to isolate angle L, so we can have here 2, not 2, but 20x cos angle L is going to be 25 plus 4x squared minus 9x squared. Okay, now we can divide stuff. So this implies that cos angle L is 25 minus 4x squared minus 9x squared. This is minus 5x squared divided by 20x. Okay, so this implies that cos L, we have a highest common factor of 5, so this is 5 minus x squared over 20x. Okay, so 5 goes once, goes 4 times. So we can make the conclusion that therefore cos L is equal to 5 minus x squared over 4x. And that's exactly what we were supposed to prove. Okay, a bit of work here. So 4 marks. I think setting up the cosine rule is key. Substituting into the cosine rule is key. Whenever we factorize, we are doing the Lord's work. And yeah, logically everything just ties up, guys, even though this was given, but it has to logically come from the top. So easy 4 marks here. Lord, this was 6. 6.2.1. Okay, so we've got 6.2.2. We are told here to give the restrictions for cos L if cos L is obtuse. If the angle L is obtuse. So we know that cos of an obtuse angle in the second quadrant would be negative. So we know that essentially cos L should be less than 0. It's a negative thing. Okay, so we know that to answer this one we say cos L less than 0. But now the question is, can cos of any angle be negative up until negative infinity? The answer is no. The limit is -1. Why? Because we know that cos theta is less than or equal to 1, greater than or equal to -1. Okay? In general. That is when theta is both negative and positive. But now, not both negative and positive, but when theta is both an acute or an obtuse angle or even a reflex angle. But we know that the limit is -1 if we go less than 0. So essentially, that is the restriction, just knowing the minimum value. The minimum value of cos of any angle can only be -1 unless we transform the entire function. So this is key, guys. So this is a low-key killer. Although it's just 2 marks, it can horrify somebody who's less suspecting. Now, is it possible for x to be equal to 6? Well, we can just look at what happens. So we know that cos L equals, we substitute 5 minus 6 squared divided by 4 into 6. This is 5 minus 36. This is minus 31 over 4. This is 24. Let's see, this is 1 comma something. So minus 31 over 24 is minus 1 comma 3 basically. Now can you see minus 1 comma 3 is outside that range, but I wish this statement was put in there, because how could one know that 6.2.3 has to be, because those two questions can be independent of each other, but the opening statement makes everything depends on it. So not quite a good placement of this, because it makes one to be not so sure as to whether we are answering the question or we are botching it. So the answer is a definite no based on this restriction, although it's not in the opening statement, which is not cool. So I feel this question here is unfair, but it's a 1 mark. So a student who knows their work would know what to do. Alright, so we have here 6.2.4. We are given x is 3. We need to calculate the area of triangle MNM, LMN to 1 decimal digit. Okay, that's easy. So we know that cos of L is what we need here. Is going to be equal to 5 minus 3 squared over 4 into 3. And essentially, this implies that cos of L is, let's simplify this one. So this one is 5 minus 3 squared. It's minus 40 divided by 12. So this is minus 1/3. Therefore, L is going to be equal to arc cos of that. Okay, so we can say shift cos the answer that we got it gives us 109.7 degrees, just to protect our final answer. So, what must we do now? Well, guys, I'm not sure if I want to suffer. I can say then area of triangle LMN is going to be equal to a half of that side. Now this side is 5. I'm just going to put it here. I'm not wasting any time. Now this one is 2 times 3 times the sine of this angle we just found. Which is equal to, so we have 0.5 into 5 into 6 into the sine of 109.47. So to just one decimal place, this is actually 14.1 units squared, and that has to come out for that answer. Okay guys, so pretty easy stuff. So here substitutions important, and essentially this angle important, these substitutions and the substitutions into a formula. So this is 1, 2, 3, 4, and then 5. Okay, so we've got our 5 marks there, nice and easy. All right, so let's move on to the next bunch of questions. So 6.3. Yo, this thing is long. Is too long. So in the diagram alongside, RT represents a vertical, the height of a vertical tower with T at the foot. So we can see this is 90 degrees. Obviously, if this is shaded, that should also be 90 degrees. Okay, because that's the horizontal plane. But let's read on. A and B represent 2 points equidistant from T. So now this means this is equal to that, okay? And which lie in the same horizontal plane. So we can see that shading is good, okay? So that makes us an isosceles triangle there. Now the height of the tower is H, indicated. Now the angle of depression of B. Now depression is from the horizontal down. So if this is the horizontal, because it's on the horizontal plane, it means that line is parallel to it as well. Okay, making it that angle alpha should be equal to this angle alpha also here. Okay, because those become alternate angles. Now we are told also that angle R is alpha there. Okay, good. RBA, it's already indicated, is beta. Okay, maybe let's give it a nice color so that we can see it standing out. Okay, so that is beta. We can see it. Not a problem. So now what can we do, guys? Remember, before we can think about any questions, if we are asked any question, which triangle is most likely the best to start on? It is this yellow one. So this yellow triangle, because if we have an angle, another angle, we can calculate the other angle, and we can actually, if we are given a side, at least we can use that. But we can also use the other triangle because technically it becomes congruent to this one. All right, so let's start answering questions without wasting time. 6.3.1. I'm a bit hungry now. Give the size of ARB in terms of beta. So we are looking for this angle here. In terms of beta. Okay, so what we will notice is that, folks, this side is equal to that. This side is equal to that side. That side is common. The angle is 90 degrees on either side, so these are congruent. So this tells us that this side must also be equal to that side. But now the question says give. So if it says give in 1 mark, so we don't need to explain why, but you have to understand why. So that angle, if those two sides are equal, and that means we have another beta here, because these are angles opposite equal sides. And now from 3 angles of a triangle, it's going to be 180 degrees minus 2 times beta. So we can say here, well, ARB is equal to 180 degrees minus 2 times beta. Okay, so we are just getting a mark here. No need to say a lot, although we could. 6.3.2, we need to prove that AB, this side right here, is equal to that story. So already we can clearly see that technically we are using this triangle right here, and we need to determine this R in terms of RB, because RB is equal to that, and then we can use either the sine rule here or the cosine rule, whatever works. All right, so let's see. We can say, starting in triangle BRT, breadth, is it breadth? Yeah, there's a town in the northwestern, is it northwest, called Breadth. Yes, near the Hartbeespoort. Is it Hartbeespoort Dam there? So yeah, is on. So let's just do the things that we can do, guys, nicely, and not waste time. This is a right angled triangle, so we want RB in terms of H, so we can use sine of angle RBT is going to be RT, which is the opposite of hypotenuse, which is RB. Now we substitute. This is sine of alpha. We don't explain anymore. We don't have time. RT is H over RB, and so that is over 1. So we can cross multiply here, and then we can see that RB, which is what we want, is essentially H over sine alpha. Okay, so that's fine. That's the first part. What do we do then? We get into this triangle here. We can say here, in triangle ARB, in there we will appreciate that essentially angle, let's just first state some things here and say RA or AR is equal to RB. Why is that? These are corresponding sides of congruent triangles with triangle ART congruent to triangle B t. Okay, in a fashion of side angle side. The spinal subarachnoid space. I don't know why I'm explaining, but I feel like it's necessary there. But we've already used that, so I'm not too sure what am I trying to do here. So what do we say, guys? We can say safely. We want AB, so we can say here then AB over the sine of the opposite angle, which is sine ARB, must be equal to, now we can use the side we just found out, which is going to be RB over sine of RAB, RAB. This is the sine rule. And this implies that AB over sine ARB is basically sine of this angle, 180 degrees minus 2 times beta. Okay, equal to this one is masiyenze kanje sithi this is h over sine alpha divided by, now sine of RAB, that is beta. Now there's no time to explain too much, guys. We just keep moving. So we have AB over, we use reduction formula here. This is sine 2 times angle beta equals H over sine alpha multiplied by 1 over sine beta. Now we keep moving. Yo, I'm tired, guys. Yo, when I guess no more now. This is sine 2 beta equals H over sine alpha sine beta. Now we can cross multiply that to solve for what we want. So this means AB is going to be H sine 2 beta over sine alpha sine beta, which also implies that AB is equal to, we can use our identities there. This is H times 2 sine beta cos beta all over sine alpha sine beta. Now we've got common terms here, that cancels. Then what remains here, we can say, therefore, municipal implies here, this is 2H, right, times cos beta times, now 1 over sine alpha, we can use the reciprocal, which is cosec alpha. Done. Okay, because this is the same as 1 over sine, which is cosec. So we can do it. So it's done, actually. Okay, a lot of work for just 5 marks. Yikes. Anyway, what is important is that. And then setting up the sine rule, maybe. And then substituting, maybe. Now this double angle identity expansion. And for cosec, let's see. Whew. That reduction formula, so many marks. 1, 2, 3, 4, 5. Maybe let's leave the sign rule. We get the marks, sometimes we don't for that. Yeah, 5 marks in the right place. Swatted. Yo, guys, this thing is so tiring. It's so tiring. Alright, guys, so we need to find the height of the tower rounded off to the nearest. And we have a formula there, so let's squeeze it here. 6.3.3. Well, we know that AB is basically equal to 2h cos beta cosec alpha. We can say here, therefore, our h is going to be AB all over. We divide by this one. 2 cos beta cosec alpha, right, which is equal to, I don't like doing this, but I have to now. AB is 5,4 divided by, now this is 2 into cos beta is 65 degrees times cosec of 51 degrees. So this should give us the answer. So I'm just squeezing. But remember, for cosec, we just need to say 1 over sine 51. That's the most important. Okay, so we've got our fraction button, 5,4 divided by 2 into cos of 65 degrees into 1 over sine of 51 degrees. Okay, so let's see, what do we get? Now we need to do this to the nearest unit. Careful. So that's 4,96. So that is essentially 5 units. Okay. Yeah, siyabangena. Now, what is the story there? 3 marks. Obviously, guys, this is the substitutions essentially, and then 2 marks for rounding off. So that's how we score those 3 marks. And if no mistakes committed, we have taken these 25 marks. This was a bit labor intensive, right? Right. Let me just chow something fast. Okay, guys, so let's get to the next question. My favorite section, Euclidean geometry. This is question what? This is question 7. Oh, okay. So what do we do here? Well, we do what we know best. Now we're told your diagrams for proving theory may be used on the diagram sheets or redrawn in the answer book. Detach the diagram sheets from the question paper. Most important, give a reason for each statement unless otherwise stated. That's the key. Okay, let's start with 7.1. We are proving angle at center is 2 times angle at circumference. So in the diagram alongside, circle PQRS is drawn. Use the diagram in the diagram sheet. Okay, great. So what are we supposed to do here? All right, we are given circle, center M, okay, masiyeke kanje. circle center M with P, Q, and S on the circumference. Okay. Kwavele kwabhaleka kahle kakhulu on the circumference. Okay. Nice. RTP. We are to prove that angle M is equal to 2 times angle P. We need to construct, right? So the construction is, okay guys, so those are the constructions we need to do. In fact, there's just one single construction. We just draw diameter PMR, that's all. And we are done. Those angles are just done. We can just say as shown. We've done it. Then we go to the proof. So what do we say? Well, we have a situation here. We know that all of these lines are ready. This is equal to that, equal to that. Those are all ready. Okay. Now, that simply says to us we can use exterior angles of triangles. So let's start and say, what do we know? We know that angle, maybe let's start and say in triangle PMS. What do we know? We know that angle P2 is equal to angle S. These are angles opposite equal sides with radii PM equals MS. Nice and easy. Because we want to use these angles easily. We can say here also, we understand that that angle M2 is equal to angle P2 plus angle S. Exterior angle of a triangle. We've already stated what we are talking about. We can say therefore angle M2 is equal to, now we've got P2 here, so this is 2 times angle P2. We don't want to use angle S because we want something to go back to angle P. So that is sorted. We can say here in triangle PMQ, what do we see in there? We know that angle P, let's just call it, let's just call it P, okay, maybe let's say QPM is equal to angle Q. These are angles opposite equal sides with radii PM equal to MQ. All right, so we move on and say also we know that angle Q is equal to angle QPM plus angle Q. This is an exterior angle of a triangle. Again, we are talking about that triangle. We can say QMR is equal to 2 times angle QPM. Okay, because we also don't want angle Q to interfere here. Now we've got a story here, we know that, but we see that angle QMR, or in fact we want angle QMS, so we can say angle QMS plus angle RMS is equal to QMR. Okay, we can just say C sketch or C diagram. That's what it is. If we add these two, they give us the big one. Okay, this implies, now what is QMS? That's the angle M that we are looking for. So we just substitute according to the original diagram now. RMS, we can say RMS, that's an M2. So we can just write here M2 is equal to, then QMR, it's basically okay, now QMR, we can see that it's basically P2 plus P1. Yeah. Why did I use P2 here actually? Okay, it's fine. Now let me see. Yeah, this is P2. Okay, masibhale kanje. QMR is basically angle P1 plus angle P2. Ne? According to our diagram, and that is the story. I'm trying to see if I'm not making a meal here. Okay. So this is QPM, but it's twice, yeah. So there it goes. So sometimes these little weird, drawings can give a bit of a challenge if one is not careful. So let's move on, guys. Let's move on. This implies that angle M, which is what we want, plus now angle M2 we said is 2 times P2. So this is 2 times angle P2 equals 2 times angle P1 plus 2 times angle P2. Now we've got like terms here, 2 angle P2, 2 angle P2. These ones will take care of each other. We can say therefore angle M is essentially equal to 2 times angle P, because the original angle P was that P1. So sometimes it is not so nice and flowy, so one has to really accommodate a lot of things. So we get a mark for our statement here. I do believe this is most important. This is most important. The substitution here and the substitution there. So this is 1, 2, 3, 4, 5. So guys, yeah, doch. But we can mark this reason once because it's similar as the one above, so that can be the 6 marks. All right, so proofs. Remember, we did proofs and their converses usually, all of them. So, yep, one has to know what needs to be known. 7.2, we are given that in the diagram alongside circles ACBN, ACBN. So if that's a circle, so this is a circle, so it's literally the smaller circle. And this becomes a cyclic quadrilateral because all the vertices are at circumference. All right, great. And then with also another circle AMBD. Okay guys, so there is our other circle. So we can see again it's a cyclic quad. And there's just that point where they intersect. Okay. We are told that CB is a tangent. So CB is a tangent to the circle at B, the larger circle. So if that's the case, we will appreciate that the angle between the tangent and the chord of that circle should be equal to the angle subtended by that chord at circumference. That's the 10 chord theorem. And on top of that, we can see that actually this big angle here, 1 and 2, is the angle between the tangent and the chord, and that chord subtends D. So again, 10 chord theorem there. Now what do we do? What do we do? We are told M is the center of the smaller circle. So if M is the center, it means this side is equal to that side. These are ready, and this already gives us yet another angle, that this angle right here is also equal to the others. Angles opposite equal sides in that triangle. Great. All right. Okay. So essentially, MB bisects CBA, okay? Excellent. So what else is the story? CAD, B and D are straight lines. So this is key information. So that means CAD, the coronary artery disease here, we can extend to D. And then this one, we can also extend to D. All right. Now we can clearly see that we can use the properties of a cyclic quad and stuff. Okay, we let A3 be equal to X. So this angle right here is X. So all of these others are going to be X. Nice. So let's start answering. 7.2.1, determine the size of angle D. Now that big one right there. So 4 marks in terms of X. So this is easy. Just going to take this to the tan chord and that, and then combine these to D. So not a problem. So what are we going to say, guys? We're going to say, well, we understand that angle B1 is equal to angle A3 equal to X. What is the reason here? This is the tan chord. That's the 10-chord theorem. We can say here also, we know that actually B2 is equal to angle A3 equal to X. These are angles opposite equal sides in triangle ABM with radii AM equaling BM. Okay, pretty comprehensive reason right there. So what do we want to say? We can say here, but angle D is equal to angle CBA. Okay, what is the reason here? This is the 10-chord theorem. So this implies that angle D, I'm tired, guys. Now this CBA is basically B1 plus B2. Therefore, angle D is 2x because each one is equal to x. It's done nicely. So this is a powerful statement. Essentially powerful statement here in essence, and we add, I don't know guys, even that reason here, it's still key because it's a different statement. I don't know, would you really get a mark for this twice? I'm not too sure, but it looks like heat. All right, so we've got here 7.2.2 with A. So I liked how our DBE papers are numbered. IEB has a very strange way. It's a very ridiculous way, actually. Anyway, leave IEB alone. We need to prove that CB is parallel to AN. So we want to prove CB is parallel to AN. Now this is a typical higher grade question where we can sweat a little bit. You can see that the marks are stating the facts. All right, now let's have a look here. For us to prove this parallelity, we can prove that angle C is equal to angle A, because that would be corresponding angles. Or we can prove A2 is equal to this B1 plus 2. That would be alternate angles, and therefore those lines would be parallel. All right, so how do we begin this attack? Well, we can start it like so. We can use this small triangle right here. Okay. You see, we can use this small triangle and say, look, this is the angle at center over here. Look for a nice color there. Maybe we can still use the same color. Say this angle at center here is 2 times angle at circumference. That's why we needed to use this proof. So this is what can help us. But that angle at circumference is equal to this angle right here. This is the exterior angle of that cyclic quad. We know that. We would know this one in terms of x, then we can calculate A1. And if A1 turns out to be equal to angle C, then we have done our job. So let's see here in the smaller circle. But we can start here and say, perhaps we want to start by saying angle M1 is equal to 180 degrees minus 2x. Okay, why do we know that? This is the sum of three angles of triangle ABM. We don't want to say too much because we already said a lot. We can say here also, no, we also know that essentially 2 times angle C is equal to angle M1. Now this is the angle at center equal to 2 times angle at circumference. It is very nice. So this implies that 2 times angle C is equal to 180 degrees minus 2x. Therefore, angle C, when we divide by 2, this becomes 90 degrees minus x. Okay, nice and easy. Now that this is done, we can say, however, we go to another triangle now. In triangle ADN, what do we know? We know that angle N1 is equal to angle C equal to 90 degrees minus x. What is the reason there? This is the exterior angle of cyclic quad ACBN. Nice. Now that we know these ones, we can say here, then we understand that angle A1 plus angle N1 plus angle D is equal to 180 degrees. This is sum of 3 angles of triangle. We've stated what triangle that is. We substitute. A1 plus n is 90 degrees minus x plus 2x equals 180 degrees. Now this implies that we've got A1 is equal to, now we'll see that this is minus x plus x, that is just 90 degrees plus x. We transpose 180 minus 90 is 90 degrees minus x. So what can we say, guys? We can say, well, it proves for us that angle A1 is equal to angle C. Why? Because each one is equal to 90 degrees minus x. Now, if angle A1 is equal to angle C, those are corresponding angles. So when corresponding angles are equal, therefore the lines are parallel. So therefore CB, is parallel to AN. We can say corresponding angles are equal, or approved equal. That's not a big deal. Since these are not necessarily theorems, but very strong statements, we can just leave it like this. So yeah, we've done our work, guys, nice and easy. So this one is important. Without it, we cannot move. This statement and reason is important. That is important. This statement is important, and essentially this conclusion is key and the final answer. So this is 1, 2, 3, 4, 5, 6. Well, maybe we can make this one the 7th mark. All right. Easy stuff, guys. So 7 marks there. Little bit of work, but not too much. Hey. So can we squeeze the last one here? Let's see if we can. It's just 4 marks. Maybe we can. We need to prove that AB is a tangent to circle ADN. So now there's a circle through AD and N. So the only way we can prove this is when we can prove that actually that angle D is equal to angle A2. Okay? And the answer is definitely yes, because we proved already that this angle B1 plus B2 is equal to D, but we can see that B1 plus B2 is equal to A2. These are alternate angles with these two lines just proved parallel. And that's done. The converse of the 10-chord theorem is sorted. Now let's see, how do we start this business? We can say, well, we understand clearly that essentially angle A2 is equal to angle B1 plus B2. Okay? Therefore equal to 2x. Why is that? These are alternate angles with AN parallel to BC. Okay, easy stuff. We can say here, therefore, we know, maybe let's give it a bit of space. Therefore, angle A2 is equal to angle D. Okay, can say here each equal to 2x. We don't need to say a lot. We can say, if that's the case, maybe we can say this implies sometimes too many conclusions are not sexy. Therefore, we can prove that now AB is a tangent to circle ADN. Why? This is the converse of the 10-chord theorem. Okay, so it fitted. Ayixhuzulanga kodwa ifitishile. Ifitile kodwa ayixhuzulanga. So it was not a seizure, but it fitted. Eh? Okay, guys, so this is key information. Linking those two, pretty intense stuff. And then we can say 2 marks for the last one, just to get those 4 marks. Again, it would depend on the actual formal guidelines for marking, which I have no idea what they look like. Okay. Anyway, guys, you can see Euclidean geometry is pretty nice. It's pretty challenging. If we did not commit any mistakes, we should have taken those 21 marks with a smile on the face. And let's move on to the next question. So we've got question 8. Yasetyenza still. Okay, question 8. So we have another proof. 8.1. In the diagram alongside M and N as 2 points on AB and AC respectively. So this is supposed to be triangle ABC. Ne? Now use the diagram on the diagram sheet to redraw the diagram in your answer book to prove the theorem which states that. Now we are proving the converse of the proportionality theorem here. All right, so what are we given? We are given triangle ABC with M and N on AB and AC respectively. Okay, nice. Now, what are we supposed to do? What we are required to prove is that MN is parallel to BC. Or we also given that AM over MB is equal to AN over NC. That is given, so that is our iyanhlanyisa iyangulisa ifuna ukuniphathisa ikhanda manje ingijwayela kabi. So now let's do the construction. Now what construction must we perform here? With the proportionality theorem, we do the same constructions that we always do. So, okay guys, so that is the construction. So we just draw perpendicular heights H and K. We then join MC and BN. Okay, that's all we do, nothing else. Then we go into the proof. Okay, so what can we say in our proof? Well, we understand that area of triangle AMN over area of triangle, which one would share the same height, is BMN. This would be equal to half. Now the base is AM times the perpendicular height, which is K, all over half. The base is basically MB times the perpendicular height is K, because this is a scalene triangle, so the height is outside the triangle. Okay, great. Now these guys will do what they do best, and that and that. So we remain with AM over MB. We can say here also, we know that the area of triangle AMN, same one, over the area of triangle CMN should be equal to a half. The base this times is AN times the perpendicular height, which is H, over half times NC, Northern Cape, times the perpendicular height H. Now these ones also do what they do best. eliminate each other out of the equation, or at least they become invisible, they hibernate, or they camouflage, because they're still there, but they don't show up. Eh? So this is AN over NC. Huh? Now guys, what do we know? We know that, but what do we know? We know that AM over MB is equal to AN over NC. We were given. Now, if we are given things, what must we do? We just do the best. So if these two are equal, therefore it means these areas. This implies that area of triangle AMN over area of triangle BMN should be equal to the area of triangle AMN over area of triangle CMN. Okay? Because I mean, if that is the condition, therefore those two, if they are equal, therefore those two are equal. But now, what do we know? We understand that the numerator is the same. So we can say, since area of triangle AMN is equal to area of triangle AMN. I mean, this is the same triangle looked at differently. What does this say? This implies that, maybe let's say this, therefore we know that the area of triangle B, the triangle BMN must be equal to the area of triangle CMN, isn't it? Because I mean, if the numerators are the same for two ratios that are equal, it means the denominators are also the same. That's just logic there. And if this is the case, we can safely say, therefore, MN must be parallel to BC, isn't it? Because these ones share the same base. Now, the base we are talking about is MN. If they have the same base, they must have the same height. And that means this is from N to that line, M to that line. And therefore, those lines must be parallel, because same height means this height is going to be consistently the same. So we can say here we have same base, same height. Between parallel lines. MN. Let's leave that one. Sometimes it's a bit cumbersome, that conclusion. Iyakhambarisha nje, iyakhambarisha, kodwa ke ikhambarishi njalo siyayamkela. Riyayiamohela. Intse ithekesela, intse le jwalo, ya thekesela yona. Conclusion yena e batla ho sa batle ho bua empa ya bua. Intse le teng empa ha eyo, wa e bona nthwena. Ya, tshwana le tseo. Is on. So let's do it, guys. So you see, construction gets a mark there. This one is a mark, this one is a mark. If we link those two logically, we get a mark for this one, and essentially that is a mark. How many marks? There's 7. So 1, 2, 3, 4, 5. We can say 6. So we know that this is the 7th mark. Makes sense. All right, so that is the story, guys. Nothing out of the ordinary. Let me drink from the fountain of life. Yo, yeah, chisana leko. Iti enja le chisa kanje. It's hot, it's hot, it's hot. But don't we say we like hot things? We like hot things. Must go back in. Let's continue. Our work is going okay for now. 8.2. Is it 8? 8.2 Afrikaans praat nou, man. Hey, must luister, man. Or else a club is going to vagervoer. In the diagram alongside ST is the tangent. Fancy words. This one is a tangent. So this one is tangential to the circle at point T. Now let's make it nice and bright. So to circle TRP, we see this one. And PT is diameter. Now diameter is also a special dude. Now if this one is diameter, what do we know? We know that actually a diameter meets the tangent at the right angles. So that angle T1 plus T2 plus T3 is 90 degrees. The entire angle. And also, we know that the angle subtended by diameter is 2 equal to 90 degrees. Is a right angle. So that is the essence of that statement. But we also know something. Hey, my friend, are dangerous. Colors is blue. Now this is the angle between the tangent and the chord. It must be equal to the angle subtended by that chord at circumference. So that is the 10 chord theorem. So it's nice to work on the diagram nicely. And then we are told here that SRQP is a second. So basically, what is the essence of this statement? It means this is a straight line. Because a second is a straight line that cuts a curve at 2 points, technically. So you see, there's many ways of expressing the same thing. So mathematical language must be, mpashash. Now, K is a point on PT such that this is the ratio. So this key piece of information must be used. PK. So this means this dude over KT over that dude divides into that ratio. So you can choose A, and then that is 2A. So remember, these are not lengths. This is a ratio. So we need to choose a multiple that keeps them in proportion. Yeah, when. And then we are told PR. Where is PR? This one. Is square root 18. Okay. Root 18 there, and then PQ is square root 2. When I get introducing numbers, uzawukhala induku nje, uzokhala induku. Maske sive bazikhala kangakanani, uzokhala izabhokwe. Utlola diphadi mona. There's gonna be cracking of whips. You see? Mos. Yeah. Someone is gonna get donored. And donored good. So essentially, guys, we can appreciate that we can even calculate RQ, you know. But the question is, do we need it? Let's see. Okay, with all of this, what can we do, guys? Yikes, yikes, yikes. I don't think there's much, and let's not even waste time trying to figure out anything now. We just move on. So we have 8.2.1. We need to prove that RT, this one, is parallel to KQ or QK. We are given that ratio. We can use the ratios and proportions. So this is A. We know that in triangle, okay, in triangle. So we see that yellow triangle there. What can we do in that triangle? This is RTP. They're required to prove things there. Okay. This is not so difficult. We can say here KP or PK. Maybe let's put it that way. Say PK over PT is going to be A over 3A. Now these dudes will just try and camouflage in the background, and then they give us a third. All right. Also, what do we know? We know that PQ over PR is going to be square root 2 divided by square root 18. Now if we simplify this one using sets, square root 2 is smaller, but root 18 is 3 root 2. So now these guys will camouflage also in the background and leave us a third. Now we can make a conclusion that therefore PK over PT is essentially PQ over PR. Right. So if that's the case, therefore the lines are parallel. So we can conclude that therefore RT is parallel to QK. Now what is that? This is the converse of the proportionality theorem. Done. Okay, easy for marks there. So obviously, guys, I suppose this is key, and linking these two in the final answer gives us the 4 marks. So Siegu B says we need to prove that this is a cyclic quad. Okay, let's see, how do we prove TKQS? Okay guys, so we can see that these are our TKQS. So how do we prove that this is a cyclic quad? Well, what we can see is that we just proved that this line is parallel to that one. Now, that means this angle Q3 plus Q2 should be 90 degrees. These are co-interior angles. But this angle plus that angle, 90 degrees, now that becomes supplementary angles. So we can get what we want. Okay. Now let's plan it nicely. We know that angle STP, standard temperature and pressure, is equal to 90 degrees. This is the angle in the semicircle. Okay, great. So we can say here also, we know that angle R1, the R1 is a muscle, plus angle RQK must be equal to 180 degrees. These are co-interior angles with TR or RT parallel to QK. Okay, which implies that angle R1 plus oh yeah sesiyesapha asikakathethi 14 into engekho yo phantse ndafa. This is basically tangent perpendicular to diameter. Sure. Ukuphapha okungaka awukakafiki wena, useza sana, khawume kancinci. We can say here also, we know that angle R1 is equal to 90 degrees. Angle in the semicircle, that's the one. Okay. We can take this one. Hey, khatha wena. Sikunhlanyisa. So we can take this one, we can say here, but that is the story. Now we can say safely, this is 90 degrees. RQK is what we want, man. So R1 is 90 degrees plus RQK equals 180 degrees. Therefore, RQK is going to be 180 minus 90. That is key, guys. Okay, all right. We can say then, we know that basically STP plus RQK is going to be 90 degrees plus 90 degrees. Therefore, STP plus RQK a supplementary. We can say therefore, maybe let's not say too much conclusion. Therefore, we can make a proof that TKQS is a cyclic quad. Now we proved that the the opposite angles are supplementary, so this is the converse of opposite angles of cyclic quad. Okay, because we know they are supplementary, so if we know it's a cyclic quad, but now we proved that these two are actually supplementary, and that means That means I'm not lady. And I got band up apparently. So that means this one is done. So guys, be systematic when dealing with this problem. So let's get the marks. So this is cool. That is also cool. And this is cool. Just 5 marks. Okay, maybe the mark is most likely here. 3, 4, and then 5. Okay, great. So I hope we've been marking everything, because this is a memo, guys. I'm going to publish it in the description together with this question paper so that you can use this as your reference when you study on your own and practice for your finals. Okay, this is for practicing for the finals. Now we're looking at triangle QRT. QRT. Phew. Whoa, 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 whoa. So akho colors ezingathi zingakhetheka zingakhetheka. Masiyithathe swa. So this is Q. Okay, this one. All right, we're looking at that triangle right there. We are comparing it to KTS. 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 So there is SK. Yeah, but that color is not impressive, is it? Startedly, ebomvu kakhulu. That is the one. That is the one. There's a lot of overlaps now. It's ugly. It's not impressive. It's not at all impressive. Got in pinned in this army. Man. Okay. This is Okay, so that is still the case. So we are comparing these two triangles. But what we notice is that that one is 90 degrees, this one is 90 degrees down. And what we can also appreciate is the fact that this angle must be equal to that angle. These are angles in the same segment subtended by chord TS in cyclic quad TKQS. Okay, if we prove 2 sets, the remaining set will do the honors. So the remaining set, it means this one. Masiyibhale kanje because says ziyafana colors should be equal to this one. All right, okay, all right. Yeah, time is flying and I have no control of it. All right, so we are done here. In triangle QRT and triangle KTS. So what do we say? What do we say? We can say here angle STP is equal to angle R1 equal to 90 degrees. Siyiprovile ngaphezulu, right? Yes, we did. We can say here also, we know that angle K1 should be equal to angle Q1. Wrong approach. Magisbon, STK is part of STP is equal to R1 in the other triangle, which is K. Okay. Doing a right la. This twisty likomiki. I've twisted the komich, so we start with the first one. QRT, that's R1, is equal to there, it's going to be STK. Right. But that STK, we better use STP because that's what we proved already. Still the same line. Okay. Also, now we want QRT, this is Q1, must be equal to angle K1. What is that? These are angles in the same segment. Okay, maybe in cyclic quad TK QS. Okay, so if we prove two sets, the remaining will be equal. This implies that in QRT, that's T2, must be equal to angle S2. We can just say remaining angles. Okay. Now therefore, triangle QRT is similar to triangle KTS, equiangular. AAA, abdominal aortic aneurysm. We made the diagnosis. Okay, 5 marks. So I think this one is good. This one is good. Hey, why 5 marks? No, 4. Okay. That one is good. Okay, then we can just gift this one. Because you see, sometimes doing half of the work above is okay. So this is 4 marks. Easy. 8.2.2 says, if PS is root 32, so this one, so this one is square root of 32. Now it says calculate, stating reasons without using a calculator, the length of ST. Okay, now that's saying something. That's speaking volumes. This is a typical higher grade question. All right, okay, all right. Sometimes we can use what we have. Sometimes it may be a nightmare. But if this is root 32, this is root 18, what is this distance right here? So what should that distance be? I think that is the key statement. Let's see, without using a calculator, we can calculate that this is root 32 minus root 18. Now this is 16 by 2, so this is 4 root 2 minus 3 root 2. So like terms, this is just the square root of 2, okay? So this means we have the square root of 2 here. All right, does this help us in any way? You know what, sometimes when there's a lot of marks, there's another set of similarities that we need to prove before we go too far. But then if we want ST, then what is this common in? Is it common? So now the clue is that we need to check if it is common, because sometimes we want to use ST squared equals to some sides that we can use. Now ST is in this triangle, the red triangle, right? But that doesn't really help us because we don't know any one of those sides. It is also common to triangle TSQ, right? TSQ as well as the big one. And then here TSQ we have SR. So TSR, sorry. We will have SR, we've calculated it. And then we want ST, yes. We can use this side also, it's given. And then ST is common, so yes. We can use triangle TSR, Strugod. Is it Strugod or Strubob? Sorry, yo guys. This thing is not ending. So let's say in triangle TSR, and let's use the big one because they each share, and then we can see the sides. So the key, guys, is make sure you look at what you have, and if it is something that you can use conveniently. So this is triangle TSP. Sithi Tsupe, ulwazi, intelligence. What can we say, guys? Well, we can see stuff there. We can see stuff there that essentially, if we start with this R2 of TSR, so we can say R2 plus R1 is equal to 180 degrees. These are angles on a straight line. Remember, we were told this is a second. Where was it? There. So that's a straight line. So this implies that R2 plus 90 degrees, because we've already proven that one. So we can say, therefore, R2 is equal to 90 degrees. We can say here also, we know that in that big triangle TSP, we know that STP, standard temperature and pressure, is also 90 degrees. We proved it above, We can say this implies, or maybe let's make a conclusion. We can say, therefore, we know that R2 from the other triangle is equal to STP in the other one. Great. Remember, we're told to put a reason for every statement unless otherwise stated. So we just simply follow the rules. Okay, so what are we going to do now, guys? We've proved one pair, but now the other pair is, yes, the 10 chord theorem. Remember that T1 was equal to angle P there, Yes, 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 yes. We can say here likewise, not likewise, but we can say, okay, we can say here, but we know that in that other triangle, T1 is equal to angle P in the other one. This is from the 10 chord theorem. Therefore, if these triangles have two sets of equal angles, we know that the remaining, so this would imply that basically TSR, is going to be equal to RTP. Ne? These are the remaining angles. Okay, nice. If that is the case, we can say this implies these triangles TSR is similar to triangle TSP, triple A. Okay, that is the story. Now that we have said what we had to say, so siyabangena. Oh. Now, guys, be careful. Sometimes when the diagram is this busy, it's overwhelming, okay? So what can we say, guys? We can say, therefore, maybe not necessarily that. We can easily say this implies. We can say then, just to break the implications a little bit, then we know that TS or ST over, now remember we're starting with TSR. This is opposite that right angle. This right angle is equal to that right angle there. The side opposite it is SP. Equals, so now I want something that will still give me ST. So if I look at this angle on the small triangle, if I look at this angle T1, because this is the side I know, angle T1 is equal to angle P, and the side opposite angle P is ST, so it's going to be SR or RS over SP. No, ST. Okay. So this is proportional sides of similar triangles. We just proved them. Then we just cross multiply here. This implies that ST squared is going to be SP times SR. So I think we need another step. Okay, that's not a big deal. We can even include it here. So that's fine. We can say here, however, we know that basically SR plus RP is equal to SP, or is it PS? This is so obvious. This implies that SR, which is what we want, plus RP, we were given this is square root 18, equals PS, which is square root 32. This implies that SR is going to be, this is 4 root 2 minus 3 root 2. Let's move fast. Therefore, SR is equal to just the square root of 2 units. Okay, we can say here, therefore, yeah, I think here we can't break the things. We must just leave the things. We must just leave the things. We must just leave the things. We can say then, we know that st squared is going to be sp is square root 32, ne? Times the square root of 2. So sibese sisithi ke ngoku, therefore st is going to be equal to an overall square root of these 2. Square root 32, which is going to be 32 times 2. Guys, that's why sending yogurt lunch. Okay, this would have been the square root of 32 by 2, and then we're taking the square root as well. So square root of the square root of 32 times 2. Okay, so this is basically 2 root 2 units. And we're not using a calculator. Okay. This is good because this would have been square root of 64, which is 8. Square root of 8 is 2 root 2. Is alright, is okay, is okay, is alright. So guys, this was a killer question. It should get 2 asterisks. It's not so easy. But simultaneous equations always are present, even in Euclidean geometry. So most of you are aware of that fact. Alright. So just 6 marks for so much work, my lord. So anyway, that is good. That is good. And then, did we use the 10-chord theorem here? No, we can mark it. It's a strong statement. And then to prove the similarity, strong 3 marks. And then 4. Then 5. Then 6. Here the marks are just jumping around, okay? Because it's all about the big effects now. It's not about the work itself. Okay. So let's do B. What is this story about B? B says we need to find KT. Hey, 5 marks. So this means we need to find the value of A and then sort it out. So we can use the big triangle, use Pythagoras, because we know all the sides now. So we can say in triangle STP. What do we know? We know that the square on the hypotenuse, SP, should be equal to the square on ST plus the square on TP. This is from Pythagoras. So now SP is root 32 equals ST, here this is 2 root 2 plus TP. Now TP is squared. Now this TP is basically 3A. Now it's gonna be squared. Okay, all right, okay. Now we want this one. This becomes 9a squared equals 32 minus 8. This implies that we've got a, okay, so if we move our fast, guys, a is going to be equal to the square root now 32 minus 8 is 24 divided by 9. Okay, so therefore our a there, 24 is basically 4 root 6 over 3. Okay, so that is the value of a. Okay, so we can see that, okay, all right, okay. So we can say that therefore TK or KT as it is said so KT is 2a basically, so it's 2 into 4 root 6 over 3, which is going to be 8 square root 6 over 3 units. So we cannot go further. We stop right there. Okay. Interesting, is it not? It is. So Pythagoras gives us the things, substitution gives us the things, value of a gives us the things, the answer. So where's the other mark? Okay, there's an extra mark, so that means every step gets a mark. Not a problem. So guys, if all went well with no mistakes anywhere, we can safely say we have gathered these 31 marks. They were rather painful. Ne? They were rather painful. Okay guys, so I'm noticing a slight mistake here. Remember, 24 is 4 times 6. Square root of 4 is 2, not 4. Oops. And therefore, that changes to 4. Okay, apologies for that. I'm just saying it as I'm drinking my wonderful coffee. Not coffee. Why do I like to say coffee? I drink tea, man. I don't drink coffee. Unless I'm driving a longer distance. Because, you see, when you're driving for longer distances. So, question 9. When you are driving for a long distance, you want to stay awake, but hey, the palpitations that I get. Question 9. I feel like my heart is going to burst open my chest, man. Alright, in question 9, in the diagram below, ABC is bisected by BK. Okay? So now, why is this thing going all dark on me now? Here one. Avele abamnyama ngathi nisuka apha ebumnyameni. Ithi ndimuvele ebukhanyeni. Because I cannot understand why it's going bright. It's going dim. Okay, it's bisected by BK. So if ABC is bisected, it means this angle is equal to that angle. Okay, like that. Okay, AP and BK intersect at H, so this means these are straight lines, so they create vertically opposite angles, and we're told AH is equal to that. So if that is the case, it means this angle is equal to that angle. Okay, so there we have it. You can see that this triangle AHK or AKH is an isosceles triangle. Obviously, guys, I need to stop teaching you guys now, because you're gonna get used to these shadings and stuff, and you're gonna struggle to sort these things out, because in the exam you just have to see these things without a lot of shading. Just make sure you are awake and aware. Okay, so we are told to prove that AB, which side is that? So AB is this side over here, over BC, which is that side, is equal to AK, okay, that side, over KC, that side. Okay, now we can see that this is most likely similarity here, because it doesn't make sense otherwise. So similarity could be using this triangle AKB, but we can see that triangle even by just looking at it, it's not similar to this one, but perhaps this one. Okay, so perhaps there's two triangles, because they look a little bit similar. That's obtuse, this is obtuse. The reason why this one wouldn't work, this is acute, 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 and yet there's an obtuse angle. So again, guys, inspection, I don't know how many times must I say that, because it's key. All right, great. So this looks like we're comparing those two triangles, but we're going to substitute AH for AK because they are equal. So this is where the trick is. So the trick is on AK. Otherwise, everything else looks fairly easy. But let's see how we go about it. 9.1. Now, obviously, these two are equal, so we can start there. In triangle ABH and triangle BCK. Now we can prove similarity so that we can use the proportional sides. So we know that essentially angle B1 is equal to angle B2. We're given that BK bisects ABC. So that's what we have. Nice and easy. But now can we see this angle H2 is an exterior angle of this triangle? If we decide, if we decide to produce this one to there, do you see that? That's an exterior angle. But this angle is equal to that, but that is an exterior angle of this triangle. So what does that mean? This means we can use that for simultaneous equations. So we can say here, we know that essentially H1, not 1 but 2, is equal to angle A1 plus angle B1. This is the exterior angle of triangle ABH. Okay? We can say here also, we can see there, let me think. Here's a better word. Likewise, K2 is equal to angle B2 plus angle C. This is the exterior angle of triangle BCK. Okay, now we've got a story though but we know that angle H2 is equal to angle K2. Why? These are angles opposite equal sides in triangle AHK. Or maybe let's give a proper reason, with AH equaling AK. That is part and parcel of our work. Now, what we can see, we can say this implies that essentially these two, when we substitute, what is H2? It's angle A1 plus angle B1 is equal to, now this is going to be B2 plus angle C. Now knowing that angle B1 is equal to angle B2, they will graciously step aside and leave us in peace. We can conclude that angle A1 is equal to angle C. So this is simultaneous equations or elimination method, whatever that is called. Now if we've made that conclusion, we can say here, this also implies that the remaining angles, which is H1, is equal to angle K1. You can say sum of three angles of triangles. All right, of triangle, not triangles. Or we can say the remaining angles. Therefore, triangle ABH is similar to triangle BCK. Equiangle. So you see, we've been using this similarity proportionality thing for so long. And remember guys, this is grade 12 work. This was higher grade, so it's always going to have tricks hidden some way. So we can say here then, we understand that essentially AB from the one triangle over, now AB is opposite H1. H1 is equal to K1. K1 has BC opposite it. They form a ratio, and then we can see that it's going to be AH over, now AH is opposite B1, B1 is equal to B2, the side opposite that is KC. Now this is the proportional sides of similar triangles. We just proved them. Now we already proved that essentially AH is equal to AK. So we can make a conclusion and say therefore AB over BC is equal to, instead of AH we're going to write AK over KC. You can just simply say AH is equal to, maybe we can just say given okay. So guys, we are done with that proof. So these are heavy questions, guys. No easy way around them. A lot of inspection of what is where and what to do about it makes life a lot easier. Okay. Great. So how do we score these 7 marks? That is a mark, truly. That is a mark. But we're not going to mark the second one. It's similar to it. But what we care about is to get there. Okay. And then this situation right there. And that rule and the final substitution. So 1, 2, 3, 4, 5, 6. So where's the 7th? Okay, maybe we can entertain that. Great. Not a problem. So that's it, guys. 7 marks. I don't know why I'm coughing now. Okay, we've been tracking our marks nicely. So 9.2. We are told it is further given that AKPB, okay, AKPB is a cyclic quadrilateral. So basically, guys, this is the picture that is given, so that there is a circle passing through A, K, P, and B. Now, what do we know, guys? Angles in the same segment will be equal. Okay, great. That is what we know is going to happen. Okay. All right, okay. So, essentially, that is the story. And then, there's nothing more we can say. Okay. And we're told that H is the center of the inscribed circle of ABC. Okay, now the center of an inscribed circle. What does that say? This demands a bit of work again. So this means there is an inscribed. So the inscribed circle is the maximum circle that we can draw inside a triangle. So let's see. So guys, basically this is again another picture drawn here, that this is the circle. Okay. So it must touch the sides of this triangle tangentially while it fits inside. So that's how we can fit a maximum. And that's an inscribed circle. Of course, if it is not drawn, this is what it means. But if it is drawn and then it's smaller than this, it's okay. But usually, when we say inscribed, we mean it must be the biggest circle we can fit inside that triangle, so that it touches the sides of the triangle. All right, so this is the story, guys. And if this is the center, now, what does it mean? What do we know about the center of an inscribed circle? So we can say the center of an inscribed circle in a triangle is called an incenter. So that's a big word. We call it an incenter. And what does that mean? And is the point of intersection of the bisectors of the corner angles of the triangle. Okay. So guys, this is the story about this piece of work here. Again, another very technical thing. Can you see, guys, there's a lot to know. This is why a lot of these things need to be taught in the lower grades, so that it's easy to use these when the need arises. Like in this case, I mean, I had hardly remembered what this means, but the clues you can pick up from the question itself. You will see that this is bisecting that angle and it passes there. So when you get stuck, you can easily just picture and say, it should also bisect that if this is the statement given. You know, sometimes guesswork given a little bit of guidance can take you through, because that's exactly what I used when I got to this question. Of course, I struggled at first, couldn't figure it out, until I decided to resort to saying, if this is bisected, that should also be bisected, because they come together. And I got my solution nicely. So let's use that theory and see what it takes us to. Now, essentially, guys, if this is an incenter, it means it should also bisect this angle. Okay. all right, okay. And from there, we can see that that angle will also be equal to that, because A1 is equal to C. So this is what we end up with. Okay, now the question says we need to find BAC. Excuse me for the noise there. My throat is throating. Stating reasons. So, I mean, if we can see that these angles are all equal and these ones are double this, so we can just use sum of 3 angles of a triangle. And we have our answer there. But it had to come from some theoretical relationships. So if these things are not there, guys, you are dead, okay? Just know these words. Inscription. When we inscribe something in something, there's a lot of theories around this, okay? All right, so let's have a look at what we can do with this now. Given the pieces of information that we had, A1 was not a part of this, but it will be now. All right. Okay, all right. So we can even use the fact that this is an incenter. Because if this is an incenter, automatically, okay, maybe we needed to link A1 to these angles. Yeah, we need to use the quadrilateral. So we can say here basically angle A2 is equal to angle B2. All right? Why? These are the angles in the same segment in cyclic quad A K P B. Okay, because those are angles subtended by arc KP. That's fine, but we also know that automatically these two were equal angle B1 and B2 above, right? We said it, didn't we? Yes, we did. So essentially, this A1 is also equal to B1. So, I mean, we can choose whichever we like here to use. But maybe let's stick with B2, because B2 can give us what we want. We will say here also, what do we want to say? We know that essentially A1 is equal to A2. Right. Why should that be? Because we can say here H is an incenter. So when we use this word that A is an incenter, ayibona ngibhala kanje. Hehehe. If we're saying A is an incenter, it means it's the point of intersection of the bisectors of those corner angles. So we just want to use this statement to avoid this long, lengthy stories there. So, what can we say, guys? We can also safely say, therefore, we understand that essentially now A1, we can say B2 is equal to angle C, isn't it? Because H is equal to angle A2. Nice and easy. So we've linked all our angles nicely. Now we can use this thing. We can say then in triangle. In fact, I may just go in and not say too much. Let's say now then, we know that angle A, BC plus angle B, AC, which is what we want, plus angle C, we must get 180 degrees. This is the sum of three angles of triangle ABC. Okay? The very basic triangle. But I'm too squashed here. I don't like it. As if I don't have space. Alright, so that is the story, guys. So we just move on. So we can represent everything in terms of B1. Okay? Sorry, B2, because ABC is 2 times B2. So we can say 2 times angle B2 plus we want this one. So we leave it like that. Plus angle C here is also B2. Equal to 180 degrees. This implies, okay, now let's not be silly here. What is BAC? It's also twice B2, because we're going to get stuck here. We're going to use B2 for everything. So 2 plus 2, that's 4, plus 1, that's 5. So 5 times angle B2 equal to 180. Therefore, angle B2 is equal to 180 degrees divided by 5. Okay. Calculate. There was no restriction, right? 180 divided by 5 is 36. But if no calculator, then long division. But I mean, who would see that? So that angle B2 is 36 degrees. Therefore, BAC, we can see it's 2 times B2 as well. So this is going to be equal to 2 times 36 degrees, which is equal to 72. Nice and easy. Yeah, my throat is doing its own things, and I don't know why. Trying to muffle my voice. Yeah, so let's mark. We were supposed to score 7 marks here, so this is 1 mark. Technically, this is a heavy mark, you know, very heavy mark, and that is also a heavy mark. Essentially here we can give a mark for substitutions, 5, 6 for that B2, 7 for the final answer. Great stuff. Okay guys, so this is 200 marks, barring any issues. In fact, we have 14 marks here. If we did not mess up anything, for a grand total of 200 marks. All right. So essentially, guys, we've come to the end of this long, lengthy review, but the intention was to teach you guys a few things that I believe if you come to know them and you see the approaches and you see the solidity in them, you will become stronger, you see. So that is very important, guys. Let me leave you with just something very interesting, you know. So there's so many things to say, but yeah, but I like the Sotho culture, you know. The Sotho culture, when they do the so-called ditog, or even us as Hlubis, we have adopted that somehow. So we do it. So you know what they say? Now this is Sotho poetry in Sesotho. Are come on, aga sekolong ke opelletse. Ke opelletse ka yona buka ya mathematics. Baithuti ha ba feta mane ba qamaka. Ha jona to ya ba sa ya laela. Nna tla thaba tsena di bathole kaofela. Haholo taba ya mathematics. Matlanketso ha eso lapeng. Ke nkile buka ka sia katiba. Thuto ka e rwala hloohong ya ka kaofela. Ke ka hoo ba mbitsa a walking textbook. Hey guys, goodbye before I run you crazy. So those who don't know what happened, guys, you just don't know, eh? I cannot do nothing. I cannot do nothing. But let me love and leave you guys, and happy practicing. Remember, the finals are coming up soon, so as soon as you finish your trials, please look at this paper. I'm going to share it in the description together with this memo. Just rub, okay, in fact, I'll rub off all the annotations. Please re-practice some questions here and see if you can see what's going on. And obviously, guys, do your best, because if you can capture these things and master them, you will go very far. But I know this is already a sin on my part, because I know some of your examiners see these videos. If they see this thing, you guys are going to get punished in the finals. And especially those who are going to write the May, June next year. These kind of things, you better make sure you go in there very clear, especially the ones I showed you. Of course, there's more for you to discover and do your part as well. I'll see you guys some other time. Goodbye.